Hello, welcome to day 3 of Unit 3. Today we're going to expand our logarithms and talk about more properties of logs. We talked about what a log is earlier, whether it's log base b, log base 10, the common log, or log base e, the natural log, ln. Some basic properties that we have here. These are very basic properties. And then we're going to go into what we're working on today is our expanded properties, where we have the product property that when we add logs, we multiply the quantities inside the logs, and vice versa. So you see some examples here. Log of 2 plus log of 3 is really just log of 6. But in reverse, log of 6 is really log of 3 plus log of 2. The quotient property is that when we divide logs, excuse me, that's wrong. When we subtract log, we divide the quantities. Okay, same idea. So log of 50 minus log of 2 is really log of 50 over 2, which is log of 25, and vice versa. And then finally, probably the big one, is when we have a power, it becomes a coefficient in front. And vice versa. So I kind of talk about this. If we have a power, it drops in front and becomes a coefficient. And if we have a coefficient, it comes here and becomes the power or the exponent. So we're going to expand some logs by making it a mini log. So when I'm multiplying here, I can expand it as log of x squared plus log of y cubed. And these exponents come in front, so 2 log x plus 3 log y. This next one, multiplication, becomes log of x squared plus log of y to the 1/2, because that's what the square root is, plus log of z to the 3/2, because I have a cubed and a square root. Remember, the square root is really something raised to the half. And if I clean this all up, it becomes 2 log x plus 1/2 log y plus 3 over 2 log z. Dividing out becomes ln of x squared minus ln of y, and then becomes 2 ln of x minus ln of y. And this last one, be very careful. This is not the cube root. This is 3 times something, so it becomes ln of 3 plus ln of x to the 1/2, because that's what the square root is, minus ln of y to the 4th, and ln of 3 plus 1/2 ln of x minus 4 ln of y. Okay, now we're going to go the other way. We're going to contract things, make it into a single logarithm. This 5 moves as the exponent, so log of n plus 3 to the 5th minus log of m. But now I'm subtracting, so I have to divide. So I have 1 log n plus 3 to the 5th over m. We're going to move these here. So I get log of t to the 4th plus log of w to the 1/2. And now I can rewrite it because I'm adding logs. I can multiply them as 1 log of t to the 4th, the square root of w, or w to the 1/2, whichever way you want to write it. I don't really care. They're the same to me. Okay, I'm going to move these guys. Ln of x to the 1/2 minus But now I'm subtracting, so I have to divide log 1 ln the square root of x over y to the 5th. And then again, this is going to move, this is going to move. Ln of 2 is by itself, plus ln of x to the 1/3 minus ln of y to the 4th. And then I can rewrite it as 1 log 2 times the cube root of x, or x to the 1/3, over y to the 4th is what I get as a final result. So many times when I solve equations that have logarithms, I convert it to exponentials by doing the curl method. I start at the base, I curl it over, so that gives me 3 to the 4th, equals, and I bring it back the other way, and the logarithm is gone, it's just 2x. 81 equals 2x, x equals 81 over 2 is my solution. I'm going to curl this, which is 4 squared, curl it back, equals x plus 1, 16 equals x plus 1, x equals 15. That is my solution. Put this up a little bit. When I don't see a base here, the base is 10. So I get 10 squared equals 2x over 5. Well, 10 squared is just 100. Equals 2x over 5. If I want to get rid of a fraction, I multiply by its reciprocal. And when I do to one side, do the other, I get x equals 500 over 2, or 250. For this one, again, I don't see a base here, but the ln has a base e. So I curl it, I get e to the 3rd is equal to 5x. And there's really not more to do here than just divide by 5 and get x equals e to the 3rd over 5. And if you want to plug that into a calculator, you can. And 3 decimal places is my rule of thumb. And I get that result. And now these last couple. So for this this next example, I need to isolate the logarithm by itself. That's kind of like one thing altogether. So I'm going to subtract my 4. I'm going to divide by 2. So I have log base 6 of 3x equal to 2. And now I can do this curl from the base to the other side. 6 squared is equal to 3x. 36 is equal to 3x. Divide by 3, x is equal to 12. That's my solution. Again, I don't see a base here. I curl it. E squared is equal to 3x minus 1 when I bring it back the other way. And then I'm going to add 1. E squared plus 1 is equal to 3x. I'm going to divide the whole thing by 3. So x equals e squared plus 1, the whole thing divided by 3. If you want to plug that in the calculator, you get 2.796. So here are some basic ways to solve equations using properties of logs. Okay, thank you for watching the video. Ask questions in class.